A man chooses. A slave obeys.
These are the words of Andrew Ryan, the creator of Rapture, an underwater city where man can make their own choices, without the involvement of governments, religions, or dictators. No gods or kings, only man. But what does it mean to choose? Now that is a philosophical question you could probably spend a lifetime on, but we are going to bypass the philosophical aspect and go straight to the source, the physics of choice.
What separates a man from a slave?
Let's start by talking about chaos. The Cambridge Dictionary defines chaos as a state of total confusion with no order. But there is always order. You just have to decode the patterns. Let's take an example. This is a pendulum. It has a very predictable movement pattern. It oscillates back and forth in a sinusoidal motion with a frequency depending on the length of the rod and the gravitational force that acts upon it. Such a system can be predicted with extreme accuracy. It has been used in clocks for hundreds of years and was the most accurate way to track time all the way up until 1930, when quartz crystals took over. Now this is a double pendulum, or a chaos pendulum as it is sometimes referred to. In contrast to the single pendulum, its movement is very hard to predict. After a few oscillations, it appears to be completely chaotic. The truth is, though, that the movement of the double pendulum is just as predictable as the single pendulum. It is just very sensitive to the initial conditions, from where you drop the pendulum. As long as we know the initial conditions with absolute precision, as well as the forces that act upon it, we can predict the double pendulum with perfect precision. The scientific studies behind these types of systems are usually categorized as chaos theory. Let's look at the definition. A scientific theory about situations that obey particular laws but appear to have little or no order. This definition acknowledges the fact that systems that appear to be chaotic still act according to certain laws. The double pendulum appears to act chaotic, but it doesn't. It acts according to the laws of physics. So the takeaway here is that systems that appear chaotic aren't really chaotic, and by extension, things that appear random aren't really random. Because according to the scientific view of the world, everything in our existence is governed by physics. Now let's steer the analysis back towards the main subject, the physics of choice. Let's start by considering a sentient being, such as a human, a black box. When a choice is to be made, information enters through our senses, the information is being processed, and out comes a choice. Quite simple so far. Now let's figure out what happens inside the human. That part is a lot more complicated, but let's break it down as much as we possibly can. Let's divide a human into atoms. Each atom interacts with every other atom that makes up the human, according to the laws of physics. That means that we can set up a system of equations on how the atoms interact with one another. If we know the initial state of each atom, we can predict how the system will react to incoming stimuli. So let's introduce external stimuli to the equation system. Now, to get the choice as the output, we will have to integrate over the time it takes to make a choice. We start integrating when the choice process begins and integrate until a choice is made. Now, the time it takes to make a choice is also dependent on parameters inside the integrals, but let's keep it super simple for now. So, now we have a generalized equation of choice. Using this, we can predict the choices a human will make with perfect accuracy, given that we know the initial conditions and the forces involved, just as with the double pendulum, and this equation can be applied to any being capable of choice. In fact, this equation can be applied to the entire universe. Just like a human, the universe is made up of particles that abide by the laws of physics. This means that with enough data and the right models for the laws of physics, everything in our universe can be predicted. And by extension, as long as our universe remains an isolated system, everything that will ever happen in our universe has already been decided. All the particles in our universe act according to the laws of physics. Nothing is random. And as long as there is no interference from outside our universe, there is only one possible outcome. So, as far as we know, everything that has happened and will happen in our universe was decided 13.8 billion years ago, at the Big Bang. How the matter that makes up our universe was arranged at the Big Bang would decide everything to ever happen in our universe. For example, whether or not you're going to subscribe to the Sun and Weather channel after watching this video was decided 13.8 billion years ago. Now, I think we're ready to answer the initial question. What does it mean to choose? A choice one would make today is essentially the predetermined outcome of a 13.8 billion year long chain reaction. The last brick in a 13.8 billion year long game of domino toppling. Choosing is completing the last part of the mechanisms leading up to the predetermined outcome. A man chooses, a slave obeys. You are obeying the laws of physics. The choice you will ultimately make was decided long before you came to be. So,
Andrew Ryan asks you a simple question. Are you a man or a slave?
but then we have quantum mechanics, and suddenly things are not as obvious anymore. Systems governed by quantum mechanics cannot be observed without changing them, and certain parameters of some systems may not be observable at all under all circumstances. This means that if we require quantum level precision for the choice predictions to be accurate, it gets a lot more complicated, as the necessary data acquisition will unavoidably interfere with the outcome. Predictions with perfect accuracy may even be completely impossible from within our universe. But even if we cannot acquire enough information on all particles to get an accurate prediction, these particles still act according to the laws of physics. Right? Earlier, we concluded that nothing is truly random, as everything in our universe acts according to the laws of physics. But let's re-examine that conclusion through the lens of quantum physics. We will do so by examining one of the classic quantum physics experiments. We have a tourmaline crystal, which has the ability to block or let through light depending on the light's polarization. Let's say we have a light source from which we can control the polarization of the light, and that we orient the crystal so that horizontally polarized light is let through and vertically polarized light is blocked. If we let the light be horizontally polarized, all light is let through. If it is vertically polarized, no light is let through. Now, what happens if the polarization is right in between horizontal and vertical polarization? Well, it turns out that half of the light is let through and half of the light is blocked. This may seem quite obvious. This is a phenomenon that we are subjected to every time we put on polarized sunglasses, and we have nice formulas in classical physics describing this behavior. But let's consider a single photon, polarized right in between horizontal and vertical polarization. The tourmaline crystal cannot let through half a photon. That is not physically possible. So, from experiments, we can conclude that the photon is let through half of the times the experiment is carried out. Once a photon is fired from the light source towards the tourmaline crystal, there is a 50% chance it will end up on the other side, and a 50% chance it will be blocked. So, what forces control whether or not the photon will end up on the other side? Physicist Paul Dirac, writer of The Principles of Quantum Mechanics, a title you might be familiar with, said that this question should be regarded as outside the field of science. So, in short, we don't know. It would appear that whatever governs this phenomena is beyond what we can perceive from inside our universe. Now, we can create statistical models for quantum phenomena such as this one, but since we're dealing with probabilities, we will not be able to get answers with perfect accuracy. The question is, will our models be good enough to determine something as complex as sentient choice? In any case, it would appear that certain quantum mechanical phenomena do exhibit what we can only perceive as true randomness, which means that we might actually not be completely enslaved by the laws of physics, as it would seem our fate is governed at least partially by chance, or possibly by something outside the observable universe.